we see this is a reciprocal function, 1 over x, which basically looks like this. This is a rough sketch. And here we see that negative would be a what? A reflection in the x-axis, and this negative 5 then a vertical translation down 5 units. So then it'll basically look like this. So instead of the horizontal asymptote being at 0, it'll be at negative 5. And so the function then, after it gets flipped, would look like this. Okay, so this is the new function we're talking about here, or new relation, sorry. And then we have to see, is this a function? Do all x values only correspond to one y value? Or do all y values only correspond to one x value? And that answer is yes. So this would be a function. And the domain, x is an element of all real numbers such that x does not equal 0. And the range, y is an element of all real numbers such that y does not equal negative 5. Okay, now we're going to continue our chat about domain and range and the functions, whether relations are functions or not. And what I'd like you to do first of all, or as we continue here in example E, the equation is x squared plus y squared equals 36. Now take a moment to think about what that function actually looks like. So here's the graph, and so that's a circle, and as you can see, that circle is centered at the origin and has a radius of 6 units. So that comes from the equation x squared plus y squared equals x squared plus y squared equals r squared, and in this case r squared is the radius squared. Okay, so now that we know that it's a circle, we can then, if we apply the vertical line test, and actually from the grid you can actually see here that any vertical line that we have will cross through the circle, or not every single one, this one and this one do not, but all other vertical lines that you could draw on this circle will in fact touch the circle in more than one place, which means that there are more than one y values, more than one y value for any one x value. Okay, so that means that this is not a function. And then we need to think about the domain and range. So what do you think the domain would be, and how would you write that? So we see that x is an element of all real numbers such that, and just like I've been doing before, this is a line and not a comma or a semicolon or any other type of punctuation. It's a line in this function notation, such that, and we see that the circle goes from negative 6 all the way to positive 6 on the x-axis, so it would be negative 6 less than or equal to x less than or equal to 6. Okay, and then for the range, and actually I like this written in this way, from negative to positive, just like you're reading from left to right along the axis, the x-axis, and these are less than symbols. Okay, that's the appropriate way of writing it. For range, think about that for a second. The range is y is an element of all real numbers such that, again, negative 6 is less than or equal to y in this case, and less than or equal to 6. Okay, moving along to example F. We see that the function is, or the relation is given as x equals y squared minus 1. If we rearrange that, we get x plus 1 equals y squared, and then we solve for y, and we take the square root of both sides. And when you have a function or any variables and you take the square root, you need the plus minus, because you don't know what that value of x actually is. Could be positive, could be negative, or sorry, not in this case, that's not the important thing. I guess the important thing here is the y itself. It could be positive or negative, and when you square it, of course, that will leave this as positive, but when you take the square root of it, this whole thing either could be positive or negative, and when you square it, you get this. So anytime you have variables and you take the square root, you need the plus and minus in front of the square root value, the radical sign. So we've got y equals plus or minus the square root of x plus 1. Think about that for a second. What would that look like? Okay, so we see here that just kind of building this up, we've got, here's the square root function. The parent function starts at the origin, 0, 0, and it just kind of increases from there on to infinity in the x direction and also infinity in the y direction. It just keeps increasing. This x plus 1, because it's inside the function itself, that means that it's going to be a horizontal translation to the left 1 unit, so that origin of 0, 0 then becomes negative 1, 0, and so that means that the positive branch will be the same as the original. It'll be increasing as x increases, y is going to increase, but the negative branch, as x increases, y is going to decrease, get further and further negative. Okay, so then this thick graph is actually the entire graph plus or minus the square root of positive, or square root of x plus 1. So again, if we do the vertical line test, we see again that for any one x value, we've got more than one y value associated with it. So that means that it is not a function. And the domain, x is an element of all real numbers such that x is greater than or equal to negative 1. And the range, y is an element of all real numbers such that there is actually no such that, because we see that it goes on forever from the origin, it goes on forever in the positive direction, and it also goes on forever in the negative direction. So there is actually no such that in this case. It's just y is an element of all real numbers. Moving along to example G, we've got 1 over x squared, and so you can identify that as a reciprocal function. What does that look like? If you just have a reciprocal function of 1 over x, what does that look like? You saw one in example D, you can take a look back at. And if it's squared, then what's going to happen to any negative x values in terms of the y? Okay, so it's going to look like that. Okay, so then using the vertical line test, we examine values of y in terms of values of x, and we see that there is only one y value for any x value. Therefore, this is a function. And take a look at the domain. X is an element of all real numbers such that, and we see that because of the denominator, what's special about when you have a value divided by another value? What can that denominator not be ever? Okay, x cannot equal 0. And the range y is an element of all real numbers such that, and we see here that in quadrants 1 and 2 the graph from left to right will go up all the way to infinity, and then on the other side of the y-axis where x equals 0, the y comes down from positive infinity down towards 0. And as you see it leveling out there, that's approaching a horizontal asymptote, which means the graph on either side will never reach y equals 0. So y, and it's of course negative, never negative because of that squared value, so y is always greater than 0.